Okay, fine. Now see, we were talking about the defects of modern periodic table.
Yeah.
So position of hydrogen was not certain there in the modern periodic table. Then dissimilar elements were given same position. Fine. Potassium
Yes, sir.
is 19 and copper is 29, but this is light metal and this is heavy metal, but both were there in the same position, first group. Both were there in the same. So dissimilar elements were given similar position and similar elements were given different position. Similar elements were given different positions and dissimilar elements were given same position. Now, metals
Yes.
and non-metals, as I was talking, they are there in the P block. Metals, non-metals, all are there together. Metals, non-metals. These are metals, these are non-metals, and these are metalloids or semi-metals. Metalloids or semi-metals.
Yes, sir.
Fine. So all elements are placed together, although their properties are different, their nature are different, but then too their position was same. Eighth group elements, 12 elements. 12 elements means iron, cobalt, and nickel. Their group is same. Their group is same. Sorry,
Okay.
their properties are different, but then too their group is same. They are there in the eighth group now. So they should be kept there in different groups, but was not. Now see, lanthanoids and actinoids. Lanthanoids and actinoids are given the separate position. Lanthanoids and
Yeah.
actinoids are given the separate position. These are lanthanoids and these are actinoids there in F block. So no individual position was there. They all were there in the third B group. Entire lanthanoids and actinoids, F block elements are there in the third B group. According to this is third A. According to the rest of the world system, it is third A. And according to North American system, it will be third B.
Yes,
It
sir.
will be third B. So we should remember this all. So these were the defects of the modern periodic table.
Okay.
So this they can ask you. Fine.
Mm.
Now we'll do this was modern periodic classification. Now properties of elements. Now
Properties of
we'll be
elements.
doing, yeah, properties of elements.
Okay.
Now we'll be doing the properties of elements. Can you see the screen?
Yes, sir.
Okay, fine. See, most of the properties we know. Most of the properties we know. Here I have written all of them together. See, I have written here S, P, D, and F capital now, but you
Yes, sir.
can't use capital. It is always a small.
Like all to
S,
be small.
P, D, that's a standard notation. It can't be in capital letter. Even if it is written there in capital letter, that's wrong. That can't be correct.
Okay.
Fine. So
Yeah.
S block elements are always soft metals. Their MP, BP will be low. Their atomic and ionic radii will be maximum and are good conductor of heat and electricity. Their ionization energy will be low and electropositivity will be high. Electropositivity means metallic character will be high. They will form ionic compound except beryllium and lithium. These are the two which will not form ionic compound, but rest will form ionic compound. These S block elements
Okay.
are very reactive and will never exist there in the free state. Will never exist there in the free state, but are highly reactive. Now see,
Yes, sir.
these S block elements are very strong reducing agents, can't be prepared by electrolysis of aqueous solution of their salt. Fine, these are very highly reactive, very strong reducing agents. So can't be prepared by hydrolysis by the electrolysis of their aqueous solution. These S block elements impart flame coloration. If you burn them, their flame will be of some specific color, except beryllium and lithium. These do not impart flame color. Oxides and hydroxides of S block elements are very strong alkali and are having great affinity for oxygen, Fine. Oxides and what this is oxide, what this is hydroxide, will be having great affinity for oxygen. So this is all about the properties of S block elements. Two more properties are there. S block elements displaces hydrogen from their acids, and these S block elements decompose water and evolve hydrogen. These S block elements, lithium, sodium, potassium, rubidium, cesium, francium, and beryllium, magnesium, calcium, strontium, barium, radium. These are S block elements. First A and second A group elements will displace hydrogen from acids and will decompose water and evolve hydrogen, except beryllium and lithium. So these are the properties of S block elements. These are the properties of S block elements. Now see what are the properties of P block elements. What are the properties of P block elements? P block elements can be metals, can be non-metals, can be semi-metals or metalloids, and can be inert gases. All are there. All are there. Now see what P block elements. These were low MPBP. These are highly or mostly acidic oxides. P block elements means non-metallic oxides are non-metallic oxides such as CO2, such as NO2, such as SO2, SO3. All these are always acidic. All these are always acidic.
Acid. Okay.
What about basic oxides? That is metallic oxides. Metallic oxides are always basic. For example, Na2O. For example, MgO. For example, Al2O3 or any other. Al2O3 is amphoteric, or calcium oxide. These are basic oxides. So metal oxides are basic in nature and non-metal oxides are acidic in nature. So this is what they have written here. You should remember this all. That's very important. The electronegativity of P block elements are very high. Most electronegative is fluorine, second is oxygen, third is nitrogen. Their electronegativity character is very high. Fluorine is the most electronegative one, and oxygen is the second, then nitrogen is the third.
Okay.
These P block elements show electrovalency or covalency. They can show electrovalency as well as covalency, both. Now, what about the catenation? What about the next property of this P block element? P block elements are having catenation property. What is the meaning of catenation? Means one atom will combine with self-linking property. Self-linking, one atom combines with another similar atom, similar element. The self-linking property of an element is called catenation. In carbon, the self-linking property, that's catenation, is maximum. That is why the number of compounds there in the organic world, means you can say organic compounds number, is very, very, very large in compared to inorganic compounds. To constitute inorganic compounds, 100 elements can be used, or more than 100 elements can be used. Out of 120 elements there in your entire periodic table, 100 or more than 100 elements constitute only inorganic compounds, and only 10 elements constitute organic compounds. What these 10 elements are? These 10 elements are carbon, hydrogen, oxygen, nitrogen, phosphorus, and sulfur. Then fluorine, bromine, and iodine. Total how many elements? 10. These 10 elements constitute organic chemistry, organic compounds, and remaining all 110 elements around will form inorganic compounds. So since inorganic compounds are formed by more than 100 elements, And organic compounds are formed by only 10 elements. So the number of variety of inorganic compounds must be larger than the
Yes, sir.
number of organic compounds, but is not so. Why? Reason is catenation. Reason is self-linking property of the carbon atom. Because of that only. P block elements have very high ionization energy. Fifth and sixth group, very high ionization energy. P block elements will form ionic as well as covalent compound, but S block elements will only form ionic compounds, never covalent compounds generally. These P block elements show allotropy. Diamond and graphite are the best example of this allotropy. This is diamond, this is diamond,
Okay.
and this is graphite. This is graphite. This is graphite. Diamond and graphite. This is diamond. Tetrahedral. And here see, one carbon is attached with 3 carbon atoms. One carbon, sorry.
Yes, sir.
One
Yeah.
carbon atom is further attached with 3 more carbon atoms. One carbon is further attached with 1, 2, 3 more carbon atoms, means one electron will remain be free. One electron will remain be independent, and that is what the reason of good conductance of graphite is. Why graphite is a good conductor of electricity? Because it has free electron, one free electron, and that electron will be responsible for the conduction of electric current. What about the diamond? In diamond, all the 4 electrons are engaged. All the 4 electrons of carbon are engaged, so no free electron will be there. No free electron will be there. But in graphite, one free electron will be there, and that will be responsible for the conduction of electric current. Fine. Now see.
Yes, sir.
These P block elements are very strong oxidizing agents, such as fluorine. That is the strongest oxidizing agent. Means will be having the greatest tendency of attracting the electron from other elements. Fluorine is having highest tendency of attracting electrons towards itself. So it is the best oxidizing agent. Nobody can be better oxidizing agent than fluorine. Fluorine is the strongest oxidizing agent because it is most electronegative. So we'll be having greatest tendency of attracting the electron cloud towards itself. Now see, P block as S block elements were giving characteristic frame coloration. P block elements do not give any characteristic flame coloration. No flame test P block elements will be given.
Yes, sir. Yeah.
So this was all about the properties of P block elements. Now see what next is. D block elements. D block elements are very hard metals because their density is very high. They will show variable valency. They will show variable valency. Most of the D block elements are colored. D block elements in lower oxidation state will be showing ionic character, and in higher oxidation state will be showing covalent character. This is Fajan's rule. D block elements are good conductor of heat and electricity. D block elements will be smallest in ionic radii. That's why their density is so high, and their MP and BP will be very, very, very high. And as we know, most of the D block elements are paramagnetic in nature. Most of the D block elements are paramagnetic in nature. Most of the D block elements will be having some magnetic moment. That is why are paramagnetic in nature. And D block elements are very, very good catalyst and having tendency of forming complexes and alloys, and having a large tendency of forming complexes and alloys. Now see, this is all about D block elements, and many properties of F block elements will be similar to D block elements only. Now see what F block elements are. Most of the F block elements are metals. Lanthanoids and actinoids have same properties. So difficult to separate. All lanthanoids and actinoids are having same chemical properties. Reason? Because their size is same. Why their size is same? Because of the lanthanoid contraction. So since there is lanthanoid contraction, so size of the almost all lanthanoids and actinoids are similar. So it will be difficult for us to separate one lanthanoid from other lanthanoids or one actinoid from other actinoids. That will be difficult. Actinoids are radioactive in nature. After U92, all elements are called transuranic. Those elements which are placed after lead 82 in periodic table, or you can say bismuth 53 in periodic table, are radioactive in nature. And those which are placed after U92 in periodic table are called transuranic elements. As D block elements show variable valency, F block elements also show variable valency and variable oxidation state. Why these two elements show variable valency and variable oxidation state? Why not S and P block elements? Because in case of S block elements, only NS electron takes part there in the bond formation. In case of P block elements, only NP electron takes part there in the bond formation. But in case of D block elements, it is NS and N-1D. Both electrons can take part there in the bond formation. What's the reason? Why D block, in case of D block elements, NS and N-1D, both can take part there in the bond formation? Reason, because the difference in energy between NS and N-1D will be almost negligible. Very, very less difference in energy between NS electrons and N-1D electrons are there. Now you'll ask me, why sir F block elements show variable valency? Because their valence S, penultimate D, penultimate D, and pre-penultimate or anti-penultimate F. All the three subshells can take part there in the bond formation. That's why they show such a large number of variable valencies. As most of the D block elements are colored, why D and F block elements are colored? Why? Because the difference in energy between two consecutive energy levels, difference in energy is very less. Difference in energy is very less. So electron from one lower energy level to higher energy level can jump very, very easily by absorbing the light from the visible region. Since electrons can jump from one lower energy level to next higher energy level very, very easily by absorbing the light from the visible region, so that is why they will appear colored. In case of D and F, both cases, difference in energy between two consecutive energy levels is very less, so electrons from one energy level to the next higher energy level can jump very easily by absorbing the light of the visible region. And you can see the light from the visible region only. You can't see the light from the ultraviolet region, or you can't see the light from the infrared region. This I have explained you there in the spectrum, there in atomic structure. So since your eyes can read only visible lights, and in case of D and F block elements, that visible light is required for the transfer of electron from one lower energy level to next consecutive higher energy level. This is also D and this is also D. So this transfer of electron from one lower energy D level to the higher energy D level is called DD transition. So because of the transfer of electron from one D lower energy level to another D higher energy level, that is called DD transition. That's why elements appeared colored. What about the paramagnetic? Since D and F block elements are having unpaired electrons, will be having certain magnetic moment. That's why D and F block elements are always paramagnetic. Their magnetic moment will never be zero. As D block elements are having tendency of forming complexes, F block elements are also having the tendency of forming complexes. D and F block elements both are having tendency of forming complexes. Complexes means complex compounds. Complexes means coordination compounds. So this is all about the properties of S, P, D, F block elements. Fine. So this also they can ask you, write the properties of D block elements, write the properties of S block elements, write the properties of P block elements, or write the properties of F block elements. So you should be well in this all. In 12 points, most of the properties, color, paramagnetic, magnetic moment, density, fine, etc. are already done. So variable valency, variable oxidation state. Not only these points, many more points are discussed, but only these points will be relevant over here, there in this topic. That is properties of block elements, S block elements, P block elements, D block elements, and F block elements. I have written all of them together. So that's all for today. Fine. That's all for
Yes,
today.
sir.
On Friday, we'll continue the same. Fine.
Okay.
Thank you.
Okay,
Thank you
sir.
very much. Bye.
Thank you, sir.
Bye.